Hi everybody, my name is Cameron and today we're going to be looking at electromagnetic waves. So previously we were looking at waves in general, now we're looking at the transverse waves that are electromagnetic. We're going to be looking at the electromagnetic spectrum as well as the different applications for electromagnetic waves. So we know that waves are going to be a transfer of energy. Electromagnetic waves are going to be electric and magnetic disturbances that transfer this energy. Okay, so it has electric as well as magnetic properties. Okay, that's why we call it electromagnetic. Okay, now as we can see here, it's a transverse wave, so meaning its pattern is its oscillation. Okay, we can say is perpendicular to its motion. Okay, it has a crest and it has a trough. And as you can see, the frequency of the wave can increase or decrease. Okay, once the frequency increases, the wavelength is also going to decrease. Okay, so a higher frequency, a lower wavelength. The gap between them gets smaller, so they can be more fitted in one area. Okay, so electromagnetic waves, we say, transfer energy by vibrating charged particles. Now, they themselves are particles, which is why they don't need a medium to travel through, which is why we can get sunlight through space, because it doesn't need particles to transfer energy between. It is energy particles. We say that electromagnetic spectrum waves travel at the speed of light. Okay, because it is basically light, okay, and they do not require that matter that we're talking about, that medium to travel through. The higher the frequency, the more energy can be transferred, okay, and therefore gamma waves have the highest energy while radio waves have the lowest. Okay, so the bigger the wavelength, the longer it can travel, okay, but the lower energy it has. The smaller the wavelength, the higher the frequency, the more energy it has, okay, but it's going to travel a shorter distance. Okay. So we were talking about in the previous lesson ionizing radiation. Okay, now we have this radiation, okay, was also going to be the transfer of energy. Electromagnetic wavelengths is also known as electromagnetic radiation. Okay, it's a transfer of energy through waves. And at a certain point, these waves are going to become ionizing. They're going to be affecting molecules, okay? But without enough energy to do that, they are referred to as non-ionizing waves, okay? So what are some of the non-ionizing waves? The first one we could look at is radio waves, okay? They have the longest wavelengths, the lowest frequency, used for communications, including mobile phones and Bluetooth, because they can travel at long distances. Okay, they can be kilometers long. Microwaves, okay, shorter than radio waves, are higher energy. Okay, they're used for satellite TV and microwaves as we know them to heat up our food. Okay, now infrared waves, this is emitted as heat. Okay, so all objects emit infrared. I think we did that in a previous lesson as well. So anything is going to be emitting infrared rays. Okay, even if it's super cold, it's still going to be emitting something. This is used in remote controls, night vision, optical communication fibers. Okay, and then after that we get visible light. Okay, now visible light is what we see. It is made up of the same thing as a microwave, radio wave, infrared. It's all made up of the same type of particles, just with different amounts of energy. The only difference is our eyes adapted to the fact that we need to see things. So we adapted to using visible light. Some animals see in infrared. It was more beneficial for them to see that wavelength than it was for them to see visible light. Although some of them see infrared and visible light. Okay, but for us, visible light was beneficial for us, and that's all we needed. And yeah, that also has a certain wavelength and a certain frequency. If those change, we have a change in color. Okay, so colors have different wavelengths and different frequencies. Red being the longest wavelength and violet on the other end having the shortest wavelength. Okay, now once we get past visible light, it starts becoming ionizing radiation or ionizing waves. It starts with ultraviolet light. It's shorter than visible light, so we can't see it. Bees can see ultraviolet light. Okay, it allows them to be attracted to flowers. It's very interesting. It's on the border between non-ionizing and ionizing, but it's still very dangerous for you. It can damage your skin, your eyes as well. Okay, and we use it to make special dyes that glow. I guess when ultraviolet light is shone on them, it is going to emit this light. Okay, it also comes from the sun as well. So when they say you've got a high UV index, it means there's a lot of UV rays coming in your area. You should put on some sunscreen. Okay, then we have X-rays, short enough to penetrate soft tissue in organisms, but not short enough to penetrate bone. So kind of like sonar, it's going to hit that bone, it's going to bounce off. And bouncing off is going to be picked up by the X-ray. We are then able to visualize bones, but not your organs. Okay, for that we're going to need a CAT scan, which is a whole different other ball game. Okay, so it's used in medical imaging and treatments as well. And then we have gamma rays. So gamma rays are the shortest wavelength, highest energy, very penetrative. Okay, not and the least ionizing of the radiations, but still the most ionizing when it comes to electromagnetic waves. Okay, so used for sterilization and medical treatments. So when it comes to communications, we said that we can use something like radio waves, microwaves, infrared. Okay, but what do you notice about radio waves that are used in telephone poles? Okay, microwaves that are used for satellites, and infrared, which are used for remotes. Okay, it's mainly going to be sort of the distance. Okay, so what we notice here is the higher the frequency, the more information it can carry. So radio waves can't carry that much information, which is why they only produce sound. Okay, microwaves can carry a bit more information, and infrared can carry even more information, which is why our optical cables, okay, for our internet are going to use this infrared light. But the shorter the wavelength, the shorter the range. Okay, which is why radio waves can be picked up from kilometers away. Microwaves, yes, we use them for satellites, but that's only because it needs it for information transmission. We have to put a lot of energy into getting at that range. It would be easier to bounce off radio waves, but they can't take as much information. Okay, and then infrared light, we can use it for our TV, very short distance. Okay, or we have to bounce it off of optical cables, which are basically just mirrors. And yeah, okay, so the shorter the wavelength, the more information it can carry, the shorter its range, and the less it spreads out, more concentrated it is. Okay, so some of the uses of these ionizing waves. Okay, ultraviolet can be used to emit light from certain chemicals. Okay, as a result of absorbing the UV waves, it's getting excited and releasing visible light. Okay, the UV waves, however, as we said, are harmful to the human eyes and skin. Okay, it can give you skin cancer. It can also damage your cornea. Okay, and yeah, it's not able to be as penetrative as X-rays or gamma rays. Okay, which are able to pass through surfaces that aren't too thick or made of a certain material. Okay, now when it comes to X-rays in medicine, as we said earlier, they are able to penetrate organs. Okay, but they bounce off of bone, teeth, metal because it is more dense. Okay. However, if you do want it to see organs, we can inject that organ with a certain, what do they call it here? A contrast medium. Okay, and that contrast medium is then going to be reflecting more of the X-rays than the organ usually would. That allows us to sort of build a picture of the organ. Okay, CAT scan machines use a sort of contrast medium, so they inject you with stuff beforehand. It goes throughout your body and it allows them to sort of pick up an image. Okay, radiation dose or X-rays can also be used. Gamma rays, I think, as well, can be used to kill cancerous cells. Okay, so you can have localized X-rays being pointed at a certain area, at a certain tumor, and that'll kill or destroy those cells. So I hope electromagnetic waves make a bit more sense now. I think it's just important to remember the uses as well as how we differentiate the different waves by their energy, by their wavelength, by their frequency, which is all kind of related as well. So as long as you know gamma rays are going to have the lowest wavelength, highest frequency, highest energy, radio waves are going to have the longest wavelength, the lowest frequency, the lowest energy, then you'll be fine. Okay. My name is Cameron. This has been Electromagnetic Waves, and I'll see you in the next lesson.